Okay, good morning class. So today we're looking at measurement. It was the revision exercise, not so. Right, so let's go there quickly. Right, so it's the revision exercise. Right, this is the revision exercise on page. The revision exercise on page 270. Yes? Right, so the first question says, calculate the volume and the surface area of the 3D objects. So let's calculate the volume and the surface area. So if you're looking at volume and surface area of that, that is now of course not a circle. It's a sphere. So the volume of a sphere is 4 over 3 pi r cubed. Okay? So it's going to be 4 over 3 pi times 6 cubed. 4 over 3 pi times 6 cubed. Give you 288 pi, which is equal to, if we send it to decimal, 904.78 centimeters cubed. Then for the surface area of a sphere, it's 4 pi r squared. Okay, so it's 4 pi 6 squared, 36 times 4 is going to give us 144, so it's 144 pi. Standard to decimal, of course, is 452.39 centimeters squared. Okay. Is that okay? Yes. Right. Just stop me if I'm going wrong. Just look at number 1B. So this is a cone, a conical shape here. The volume is equal to a third area of base times perpendicular height. So it's a third. The area of a circle is pi r squared. So it's pi times 11 squared times the depth of the object, which is 12.3. That's going to give you a third pi times 11 squared times 12.3. Can you give us 4,961 over 10 pi, which is 1,558, 5 millimeters cubed. For the surface area, it's going to be pi or s slanted height plus the area of base, which is pi r squared. Is that correct? So in other words, I must calculate the slanted height here. Not so. So the slanted height squared is equal to 11 squared plus 12.3 squared. So the slanted height works out to be 12.3 squared plus 11 squared. Square root thereof will give you 16.5 millimeters here. That is simply going to give you pi times the radius, which is 11, times slanted height, which is 16.5, plus pi times the radius, which is 11, the squared. Okay? pi times 11 times 16.5, 0 and the number carries on, plus pi times 11 squared. 950,37. 950 millimeters squared. Okay, any issues there? No? Okay. Let's see what's going on here. Number 1C. Spoke about this already. Turn this over. Okay, so again, is the surface area and the volume that needs to be calculated. So if you look at the shape here, remember for this volume is equal to area of base times height. Okay, so to calculate the area of this base, okay, we're going to assume that that is at the center of the circle. Okay, so the area of this base is going to be pi r squared times height. But since there's a slice cut out of this, okay, there's the issue arises there. So if you look at this here, we need to actually work out, that's your radius, how much of the circle is cut out, how much of the circle is cut out. Okay. So if you're looking at the circle itself, the area of the circle is going to be pi r squared, okay? Now, what is given here is the circumference of the circle, or part of the circumference of the circle, which is 25 centimeters. But this whole circle here, circumference of the whole circle, is going to be, excluding the cut out part now, no, the whole circle, it's going to be 2 pi r, which is going to be 10 pi, because your radius was 5. No? So I need to know how much of the circle is cut out. So the circumference is going to be what is left is going to be 25. So when we look at the fraction of how much is actually lost, which is this part here, okay, I just added my, let me just check again. So the part that is lost, a fraction of what is lost. So I was going to now say the ratio is going to be 25 over 10 pi. Just check what we get in here. 25 over 10 pi. 0,795. So the 0 is the ratio is 0,795. The number of course carries on. Okay, we just check how far off are we, okay. So 0,795 pi, the radius is 5 squared times the height, which is 8. Let me just check quickly something, okay. So it's going to be answer times pi times 5 squared times 8. I get 500. What's the answer? 499. So the answer is 500 in other words. 499 is 500, not so? Right, so that is correct. 500 centimeters cubed. Okay, so what I did was, I calculated the ratio of how much is cut out. Okay, you guys understand? Because this is not 90 degrees here, so I can't just assume it's 90 degrees. Can you see that? So I just calculated in terms of a ratio how much is lost. Then how did I calculate that? By calculating the circumference of the hole. Oh, sorry, the circumference of what we have over the circumference of the hole. That is basically how much of the area is remaining. Can you see that, people? So that is how I work it out. Then, for the total surface area, how do we calculate that? Is the perimeter of base times height plus 2 area of base. Okay, so the perimeter of this base, of course, is going to be the 25 plus 5 plus 5. Not so. So it's going to be 25 plus 5 plus 5 times the depth of this object, which is 8 plus 2 area of base. How do you calculate the area of the base? It's 2 pi r, which is 5 squared. But is the whole base considered? No. Only 0,795 is considered. You guys understand? So multiply this by 0,795, or closer to the correct answer would have been the ratio, which is 25 over 10 pi. Okay. So that's going to give us, open brackets, 25 plus 2 times 5, which is 10, close bracket, times 8 plus 2 pi times 5 squared times 25 over 10 pi. It's 405. 405 centimeters squared. What's the answer? 404.96, the same as 405. Okay? Let's look at the next one. Yes. You see, what I did was I worked with 25 over 10 pi. What they did was they worked out the ratio of 0,795. Okay. Or you can go 2 decimal places or 1 decimal place. Whatever they use. But because my pi cancel them, that is why I get these answers. Okay. I always try and work with pi as far as I can. Let's look at number 1D. Number 1D. Again, we have the area is equal to half, a third area of base times perpendicular. So it's volume. Okay, so it's going to be area of the space. How do you calculate the area of a circle? Pi r squared. Not so. Pi r. Going to be pi r, which is 5 squared times the depth of this, which is 7. There has to be 7. Now, is the whole, the area of the whole circle considered here? No. This part again cut out. So what we do is we say that the ratio, as I did it before, so then put the 7 on this side. So for the area of the base, I'm considering. Okay? I'm going to calculate the area of this full circle. It's going to be pi r squared, not so. So it's going to be 21, which is the circumference of that, of this part here, which is 21 over the area of the circle, which is pi. My radius is 5 squared. Okay? So that is simply going to give us the third times pi times 5 squared times 21 over pi times 5 squared times 7. I get 49. What's the answer? Sorry? 120. 122. 14. Okay, so let's look where's my mistake. 48. Okay. 122,48. Okay, 1448. This is what is important to me now. Okay. So it's going to be area of base, a third area of base, so it's a pi squared, times the ratio, 21 over 5, times height, which is 7. Okay, where am I going wrong? Yes?
So why is your pi squared over pi squared? Why is it pi squared?
Because I have the area. Oh, that's my mistake. Sorry, man. Thank you. I'm working on area. Supposed to have gone with the perimeter, yes, with circumference. Sorry. So it's going to be 2 pi. Radius is 5. So 2. And I should get 122.5. Thank you, no? 122.5 centimeters cube. Then the question was with regards to the surface area. So surface area is going to be power squared, power s plus power squared. So if I look at the triangle here, I have a triangle we're looking like that thing. Not so. With the slanted height equals 7 squared plus 5 squared. So your slanted height works out to be 7 squared plus 5 squared. 74, the square root thereof is square root of 74. So it's going to be pi times just hang on. The radius is 5. The slanted height is going to be the root of 74. Right. But what I'm considering is the fact that there's part of the slanted height that is cut out. Not so? And how much of the slanted height is cut out? This ratio is cut out. Can you see that, people? So that I must multiply by 21 over 2 pi times 5. But with that being cut out, something else was added. Not so. What is added is this here. Can you see this? Those two faces are added. That one and this one here that you can't see much now. Those two faces are added. Okay? So I must say plus. The area of that is a triangle. Not so. So it's 2 times of, what's my base? 5 times my height? 7. Plus power squared, which is pi. My radius is 5 squared. But is the full circle considered there? No. It's times the golden ratio here, which is 21 over 2 pi times 5. Okay. Let's see. We got pi times 5 times the root of 74 times 21 over 2 pi times 5 plus 2 times a half times 5 times 7 plus pi times 5 squared times 21 over 2 pi times 5. I get 177,82. What's the answer there? with 8-1. Come on now, Aaron, man. But okay, you guys understand? This? The volume is normally 3 or 4 marks. I will give you 4 here. Okay? For the volume. The surface area is what is.
Yeah.
Okay, so I will give you 5 or 6 marks in surface area. Okay, so something you must take apart here. Yes, Michael?
Are you allowed to use your phone?
Yes. Yes.
Okay, so explain that, like to try and
You see, if you're looking at the surface area is everything that's exposed to the outside. So when they cut this in blue here, if they cut that out, can't pick it up here. If you cut that cone, or you slice that cone, where you see that blue there, then that becomes the surface area now, or part of the surface area of the shape. Understand? Yes, Michael. Yes. Yes.
Okay, so then why didn't you do the same thing in the within the phase of
We did. She's saying, why didn't I consider this blue section? Let me show you. You probably didn't see, but I did. Who can tell away? You don't know. What did I write here? Perimeter of base times height. If you look at this base here, the perimeter of that base was that 25 plus that 2 5s. Can you see that? Times the height would have given you that thing. Not, oh, it's a rectangle. No? So I have considered those sections as well. Anybody else? You're on a rough ride here. No?
Yes.
Okay, now it gets better. Don't worry. So now we are told, and the first time for the year, okay, and some of you are told last year as well, it's the first time so many of you can, please explain this, please explain. So it looks like some of you are doing your work. Okay. Not many. Alright. So we are told in number 2 that the cone shows here as a radius of 5 centimeters and a height of 12 centimeters. Determine the volume and the surface area of the solid. So if you look at the volume is going to be a third area of base times height. So it's a third area of base, which is pi r squared, times the height, which is 2. So it's going to be a third pi r, which is pi r squared, times the height, which is 12. It's 100 pi, which is 314,16. 314,16 centimeters cubed. If I look at the surface area is going to be pi rs plus pi r squared. Okay, so we got pi, the radius is 5, the slanted height is the square root of 5 squared plus 12 squared, which is 13 there. Not so, plus pi, my radius, which is 5 squared. Okay. I know some of you do this in the sum as well, no? You guys must do that in one. Okay, normally I do it apart, but it can be done in one, there's no problem with that. That gives you 13 plus pi times 5 squared. It's going to give you 90 pi, which is 282,74 centimeters. That correct? Okay, any issues here? No? B says, almost skip that now. B says, if each measurement is increased by a factor of 3, calculate the new volume and surface area. So, the volume of the new shape is going to be K cubed times volume of the original. Not so? We spoke about this in the previous lesson. So it's going for a factor of 3. So it's 3 cubed times 314,16. You guys understand? Okay, so that's going to be worked out now. And on the other end, we have the surface area. Okay, so this is number 2 here. So the surface area of the new one will be k squared times the surface area of the original shape. Okay. So it's going to be 3 squared times 282,74. So it's, the reason why I wrote that and didn't complete the first one was so this answer is already on the board. We multiply this by 3 squared, which of course is 810 pi, which is 2,544,69 centimeters squared. Whilst this here is going to be 300. No, that's 227 times 100 pi, so it's 2700 pi. So that's going to be 2700 pi, which is 8482, 3 centimeters squared. Is that correct? Okay. Any issues here? No? Then number 4 is sphere. Number 3 on page 270. A sphere of a radius of 23 is enlarged by a factor of 4. Determine the surface area of the original as well as the surface area on the enlarged sphere. So if we're looking at the original sphere, there only one surface area. No? Surface area of a sphere is 4 pi squared. Not so. So it's going to be 4 pi. The radius is 23 squared, which is 4 pi times 23 squared gives us 2,116 pi. 2,116 pi. Then the surface area of the enlarged sphere, this is for the E for enlarged. Surface area of the enlarged sphere is enlarged by a factor of 4, which means to say that the radius, which also know it's going to be 4 times 23. Not so. So there's going to be pi. So the radius of the enlarged sphere is going to be 23 times 4, which is 90 something, no? Minus 8 is 92, I think. Yeah, 92. Yes? So what did I ask? Determine the surface area of the original as well as the enlarged. Yeah, you could have done that as well. Oh, okay, I see what B is asking. I thought they were going to ask to work out the ratio here. Okay, but it's fine. What you say is absolutely correct. The surface area of the enlarged one would be k squared times the surface area of the original. Not so. So it's going to give you 4 squared times 2,116 pi, which gives us 4 squared times 2,116 pi gives us 33,856 pi, which is the 106,361,76 centimeters. Units actually. Why? Because I have units here. Units squared. Okay, and this is going to give us that is 6647, 6647, comma, and 61. Okay. Any confusion there? This is correct? Okay. And then the question is with regards to the volume. B was volume. Now how do you calculate the volume of a sphere? Is 4 over 3 pi cubed, which is 4 over 3 pi 4 cubed. 4 cubed is 64 times 4 is 256 divided by, yes, 23. That's my mistake. This is going to be fairly large, so I'm not going to work this out in my head. It's going to be 4 over 3 pi times 23 cubed. Oops. So they give you that number there, which is 50,956. 50,965, not 56, comma 01. Okay? Units cubed. Now the volume of the large figure is going to be K cubed times the volume of the regional. So it's going to be 4 cubed times 50,965,01. So you take it answer times 4 cubed. Okay, it gives you 326,000. 326,000. No, there's 3,261,760. Is that correct? Comma 6. Units cubed. Remember that if something is lost to a K factor, it's going to be in area K squared, in volume it's going to be K cubed. Okay. Is that it? Huh? Right. So that basically brings us to the end of measurement. Yes? We normally just deduct. I shouldn't tell you this, but I could rather not. Yes, we're going to deduct. Not there. Okay. No, normally we deduct once. We are nice people. You understand? So, say you lose your rounding off mark in question 1. We won't penalize you again for your rounding. But we want all our marks, don't we? So round the prop. Okay. So within a sum, if the question, like our papers normally say round to 2 decimal places. Or throughout the paper, when we work with angles, when we work with anything. Okay, and so if you mess it up somewhere, and then we penalize you, and then we don't penalize you again. Another thing is that when you're working with the sum and you want all your marks, work to 4 decimal places within the sum. And you final answer around to 2 decimal places.
Because when I was doing 1, 2, C, and D, I had in the textbook they rounded off the fraction.
They rounded off earlier.
Yes, they rounded off the fraction in order to get like the those decimals.
But I worked with it.
So did I.
Yeah. Okay, now you see now I'm feeling better because you're now thinking like me. Alright, so anything else, people? No? We'll call the store closed.